Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Introduce Farouk Khan from Ohio State University. Farouk has a joint appointment between the Department of Electrical and Computer Engineering as well as Department of Anesthesiology. Got it right that time. And we've been working with Farouk since 2002 when we first released what was called a GXA, request for proposal, and looking at how we could utilize web services in unique and innovative ways. And Farouk and his students have actually taken it and kind of gone forward with it and used it really in a pretty unique way within the operating systems at their medical center, and started from ground zero and now are actually involved with like the Indigo TAP program and things like that. So Farouk will go through what they're doing now and also what they're looking to do for the next generation. Thanks.
Thank you for coming to the talk. The topic is using emerging open specifications for enhancing XML web services. But really, another thing I'm going to talk about is we're involved with Indigo, and we are going to use Indigo in a lot of our things and port our systems to Indigo. And really, when we deal with Indigo, we don't have to think too much about open specifications and things like this. Everything is taken down to the infrastructure level. So the topic is more WYSI-like, but in Indigo, we wouldn't really think about these. Everything will happen at the protocol level. All right, OSU, Buckeyes, that's where I am from.
That was better when you guys were national champions, though.
Yeah. Next year. Okay, so it's a very big team. We have a big team from College of Engineering. A lot of PhD students, undergraduate students. All this stuff is considered really cool, so I got lots of students working on this. We have also a team from the College of Medicine, and from that side, we really need administrators, managers, things like this. And so we have all these people on the team, so we have easy access to the hospital. Okay, it all started, this work really started, as Dan said, in 2002, when there was a request for proposals on what these services were known as global web services. WYSI was known as global web services. And we submitted a proposal by this title, and the proposal got funded, and we really started from scratch. Okay, and I remember Dan came early on in 2002, and we had no idea. At that time, we hadn't made any plans of what we were going to do, and we went to the hospital and things like this. And after that, it has been really a big success. That's me in Executive Circle magazine. There's one of the articles under Homeland Security. A lot of things have happened since we started this. We had 2 major case studies were done by Microsoft. We were in a whole article on Microsoft Executive Circle magazine. We were in the customer panel at TechEd 2004, and we wined and dined with the PR people at Microsoft. They really know how to have fun. We were also the lead for the Microsoft announcement for WYSI 2.0. So we're still on some place in Microsoft web page. And really, we were the first production system in the world which is based on WSTAR standards, secure conversation, trust, and policy. And the production system is still running today. And so what I'm going to talk about today is about the production system and how we are extending it and new things we are doing and how we are collaborating with the Indigo team. We're the only university in this very exclusive 11-member Indigo TAP program. And I just came from the SDR, TAP SDR. It was very intensive for 3 days. We were given very, very, very intensive and very impressive education on these things. Okay, so whenever you see the big context of whatever I'm going to talk about is this holy grail. This is what everyone is wishing for, is an electronic medical record. Okay, and if President Bush on national television has mentioned a couple of times the importance of electronic medical record. They're just unacceptable high rate of errors, and we need to go to an not a paper-based, but an electronic medical record. But the problem is, it's easier said than done. There are lots of issues, and because of standardization, security, data entry, integration, policy, when your medical actions have to cross policy boundaries, they have to go from one hospital to another, or they have to go from one hospital to insurance companies. And all these things make it extremely, it's a very tough problem, okay? And so our big vision is to tackle this problem. Okay, the nice thing for us is that we have one of the nation's biggest hospital at our disposal. We have got full security clearance. We have access to the security, the operating rooms, anything we want. The hospital actually consists of 4 different hospitals. I've only shown 3. Here's the new Richard Ross Hospital, state-of-the-art facility. Really very highly ranked. It's completely wireless connectivity. He's gotten the most wired hospital award many years in a row. It's a huge hospital. It has 50+ operating rooms, and that, by any standards, it's very big. And the mission is patient care, education, and research. And the research we do and the production system we build are all under this mission. Okay, so the first system you will see today will be related to an operating room, and on the anesthesiology side of the operating room. So what you see over here is the patient is behind this blue curtain, so the patient is behind there. You've got the area of anesthesiologist. These are infusion pumps. The infusion pumps are infusing medication. Here's a medication cart where there are all the syringes. And the anesthesiologist have these concoctions of their own recipes of medications, and then they put them into the infusion pump and program them in their own ways. Here you see all the transducers for ECG, blood pressure, cardiac output, etc. These are all connected to the patient back there, and all the vital signs are being seen on the monitor. So before we started this project, that's where you could see the vital signs. You couldn't see the vital signs outside. On top of that, here is the high-tech recording which is being done in all hospitals today in the US. There's a little pad, and it has an anesthesia record. And after every 5 minutes or so, the anesthesiologist marks this pad. And whenever these drugs are administered, also marks them there. But sometimes in the heat of the battle, these things are forgotten, and a lot of these drugs are never recorded. These drugs are extremely expensive. These are all narcotics. They are kept under huge locks and keys, and you can't even miss a single drop or half a drop of these things. Yet, these completely are not recorded, and hospital loses quite a lot of money just because of things like that. So that's the state of how things are being done. And our first job, our first system we built was to take care of these things, build a system which would take these vital signs and show them outside, also make correlations with medication actions that are given. The job of our system would be to see these vital signs securely anywhere, not just in the OR, but anywhere else in the hospital, in a surgeon's room, or even in their homes. Okay, and everything has to be done completely securely. You should be able to record it. You should be able to replay it later. So we did very extensive domain analysis. The team spent full 4 hours in the operating room complex without having any preconceived idea about what we were going to do or exactly what type of architecture we will use. We just went in and spent 4 hours. We would go there early in the morning, and at 6:30 when the operating rooms opened, and we were there. We observed everything. We followed patients. We followed nurses. We followed surgeons. We interviewed them. We looked at every form. It was a very, very extensive study of the workflow. And only after doing this extensive study did we write a single line of code. And I think one reason for our success is this 4 months of domain analysis, and we built domain models before we even touched a single line of code. And we saw a lot of shortcomings, which you have already seen in that slide I showed you of the operating room. But there are a few other things which we are also working on, which you didn't see there. It's very hard to track patients. Patients get lost. Patients sometimes are taken to the wrong place. And especially if a patient is under anesthesia, that can be a problem. It's also hard to track equipment. Surgeons come, they borrow equipment from one operating room, then it disappears. Another surgeon needs it. You don't know where the equipment is. Also, the medication entry, as I showed you, is manual. So there are lots of these shortcomings, and the system I'm going to talk to you about solves lots of these problems, and some new systems on tracking will solve some of the tracking problems. The first thing we did is a conceptual thing that we said anything of medical relevance that happens to a patient to an operating room, to equipment, is a medical action. And so these are all medical actions: vital signs, medication actions, even position actions. When a patient is moved into an OR, that's an action. The patient has gone in. All of these are considered medical actions. All of these are considered relevant. Radiology actions, other type of actions. Then we have a concept of records. Basically, a record is just a collection of actions. So if you collect all the actions that are associated with the patient, then it's a patient record. If you have a collection of all the vital signs, then it's an anesthesia record. The paper you saw in the first slide is electronically, you can just think of it as a collection of vital signs action. In the same way, OR record, equipment record, things like this. You can have medical records associated with equipment. All of these derive from the same thing, the same concept of a record. And therefore, all of these can be seen in a uniform way. Therefore, all of them can be displayed and looked at uniformly on a timeline. So here's just a slice of some client pulling out the data of all these actions and displaying it in some way. So here's a location action, which our service OR track takes care of. It says the monitor has gone in, certain monitor has gone into an operating room. Here is another location action, which is saying a patient has moved in to the operating room. Each one of these is a vital signs action. This one is a medication action, which says that the medication has been administered. So notice you have correlation now between medication action and vital signs action. So later I'll show you our clients which show these timelines and you can use them to see if the medication, if your vital signs look abnormal, and if they happen around the time when the medication is administered, then you can make cause and effect type of things, which before you couldn't. Before, whatever you're seeing over here would be this huge stack of paper, uncorrelated with each other, sitting in huge cabinets.
So how do you actually, and I'm sure you'll probably get into it, but how are these things actually entered into some sort of a system?
Okay.
Are they barcode things for the monitor, for example, the equipment that's going in? You know, how are those things actually entered into this system, these actions?
Okay. We have got different systems, for example, vital signs. And as an XML concept, we have a concept of an action, and then we have concepts of vital signs actions or other actions. And so over the wire, they flow as things which are known as actions, and then we dump them in databases. Then we have different things which will produce these actions. So at the monitor level, when we pull something out of the monitor, it'll get converted into an action at once.
That's easy enough.
Yeah. And so everything is very loosely coupled, and just at the source, things get converted into XML. Whatever we do, we just put it into XML, conform to a schema, and later I'll show you that all our XML schemas have information about hierarchies. In other words, let's say there's an inpatient and there's an inpatient. Then over the wire, you know that an inpatient is a patient. So when you add new types of patients, the system doesn't break. It'll still knows it's a patient, so it'll keep on treating like a patient unless you put schema in and override it. And so the way we have built the system is it's very, very flexible to additions and changes. So
I guess what I'm asking is slightly higher level, and that is, in the previous slide, you showed the monitor coming in, and then the fact that somebody administers some drugs.
Yeah.
And I guess what I'm asking is, how are those now different than going to paper? What do you physically do to monitor those things? Does somebody barcode the machine that's coming
okay.
in?
So the vital signs are automatic.
Yeah.
They come out automatically. The medication thing is a touch screen,
Yeah.
where the doctor would simply presses the screen. The position actions, which I'll talk about later, we're going through different ways. We can plug in different technologies into that. Right now, we have a technology which is wired, which is called WiFi Locate.
Yeah.
So when the patient goes into the OR, you simply plug the patient in.
I see.
And then you know that the patient is in that OR. The second thing we are doing, and we're looking at modes and things like for very small Wi-Fi things, is to use the existing infrastructure of the hospital to do Wi-Fi tracking. And then those tracking things will send out tracking actions. And everything goes then into a series of databases. And within the database, you know that these are actions, and then you pull them out. Okay, so these are some of the very strong high-level requirements we had. We wanted it loosely coupled, secure, highly available, scalable, should allow inter-hospital collaboration, standard-based federation, not centrally controlled, self-healing. Most of the things you'll see are Indigo will help us a lot in a lot of these things, because if you look at what Indigo is meant to do, a lot of these things are in those requirements also. Okay, so now I'll just give you a very big picture of the whole suite. So what we have is a suite of products, solutions, not just one solution. OR Track is what is already in production and is being used. I'm sorry, not OR Track, ORI. So ORI is the system which takes information from vital signs and makes it available to be seen outside in other places. It's based on a federation of web services. These web services are made secure using WYSI. So we have WS Security, WS Secure Conversation, WS Trust, WS Policy. Everything is taken care of by WSI at the infrastructure level. So we don't have to do a lot of worrying about that. Okay? A lot of our code is cleanly separated between config files for WSI and the actual business logic that's done in code. And these are the different ORs. OR Track is the system, which I'll also talk about, and this should be done by the end of in three to 4 months. And we're building it entirely in Indigo. So we started from scratch, and we will design it with Indigo in mind. We are also taking ORI and porting it to Indigo completely. And here's USB Locate I was talking about. That's one service which uses USB. But we also have other things like Wi-Fi Track, which we are planning. And we also would like to interact with Microsoft Research because they have done some work on Wi-Fi tracking types of things. So that we have tracking using the existing infrastructure in a hospital. So you don't have to add extra transceivers or anything. You just use the access points in Wi-Fi and using stochastic processes, which were actually started at Microsoft Research, use those to actually track patients around. Okay, and then we have OR medication, and that's part of it is done, part of it is on hold. That's where using a touch screen, you can just say, okay, I've administered this medication, action is generated, goes into the database, then clients can just look at them if they want to. Okay. Another thing is all the clients can be on laptops, they can be pocket PCs, they can be flat panel displays, different types of things. So we have the whole system uses also the .NET Compact framework, and we have made bridges so that the system completely talks with a system which has got WSI in it. Okay, and okay.
So I have one
Yeah.
other question.
Yeah.
That is, so what makes you think that people would use a touchscreen monitor more than they would use a pen to write something down?
Voice activation, they would like even more. Anything we do has to be faster than writing the pen. So first we came up with, we used InfoPath forms, and what happened was that was taking them longer. And that was, so the touchpad thing is just a thing with very big buttons. And you simply admit it and you just touch it. And that's actually faster. But,
All about speed.
right, it's, if anything is slower than what they're already doing, you'll never let them use it.
Yeah.
It has to give some value to them. And that's why we spent 4 months in the hospital. Without that, we would have made a system. By now, I'm sure that system would it would have been failure from day number one. Because every meeting we have domain experts in there. So every meeting, we have we have got 3 meetings a week on this thing. Each meeting goes from 2 to 3 hours, where we get, and every meeting we have a domain expert, someone from the hospital sitting in there. Because very often, some of my students come up with the most crazy ideas which get which get vetoed right there. So this just tells you the collection of services we have in the ORI, just the part that looks at the vital signs and also the touch screen medication part. We have different types of routers to hide different types of brand name monitors. We have GE monitors, other types of monitors. And so the system just talks to these. So these are routers at a higher level, at the WSI or Indigo level. So we can go and change monitors and things like this. These monitors talk with different protocols, the back end. But on this side, everything is exposed in the same way. As you can see, we have a desktop client. I'll show you some pictures of that. We also have smart clients. This shows you a little bit more in detail. I'm not going into a lot of technical details, just give you an idea that But when we started doing this web services, we learned a lot, because when we started doing web services 2 years ago, we had no prior experience in doing web services. And so it took us time, and also we interacted with Microsoft a lot, with the Visi team, and right now we're interacting with the Indigo team. So all these talking with Microsoft and getting advice and doing our own pitfalls, we figured out how to use web services. For one, web services shouldn't be used for everything. They should be used for where they're really needed. And number two, web services should be used should remain highly available. So you should just use them very short period of time. And the architecture we came up with was basically you talk with the web service puts this thing in a queue, then some other web service comes and picks this thing out of the queue and deals with it. So you have got very loose coupling. Only two web services know about each other. Everything else just goes through queues and picks things up. These are persistent queues. Even if the machine goes down and comes up, the queues are still there. So web services should do very light work. And for heavy work, you can use enterprise services in the back end. And if you use enterprise services, then you can use the full transactions. You can use all the COM plus type of things in the back end. And we have, and those enterprise services could be running as Windows services. So the system is kept loosely coupled and also highly available because of the way we use queues, and also the way we only use the web services for very quick things. The system is also made highly available, multi-threaded. Another nice thing about the system is it's completely self-healing. By that I mean is every monitor or anything that is using the system deposits leases in queues. And if somebody pulls a plug on a monitor, or if the monitor is not used anymore for some reason, then the lease will not be, it's like a heartbeat. So the lease will not be renewed. The system will reclaim the resources. Not just monitors and other things, but every thread. The threads we run in the system also have leases. So and the monitor, okay, let's say they're queues. And in those queues, the monitors are depositing their data in the queues. Okay, there are threads which go in and pick data out of these queues. But if the thread, and there are also lease queues where the clients say, okay, I'm interested in getting this information from this monitor. So the thread monitors the lease. If the lease is not there, or the lease expires, then basically that thread stops looking at data, and it commits suicide because we don't want too many threads running. But what if the thread hangs? So every thread also deposits a lease. So all the queues have threads. Each thread has its own lease, and a master thread monitors those threads. And if a thread dies or hangs up, then it doesn't renew its lease, and the master thread kills it. So either they commit suicide or they're killed in the end, and then the system goes down to a very known state. The system has been running for more than a year now, and it has been running very well. It has been running constantly, and it's been running in a known state. Okay, you can go and pull plugs. You can do all sorts of things. The lease-based system brings the system back to a very normal state. There's a professor at University of Illinois. He's one of the guys who designed the International Space Station, or not designed it, but designed the reliability parts of that. And when he came and visited at OSU, he was really impressed by how our system remains stable under pulling the plugs and all these types of things. As a matter of fact, he was going to China on a sabbatical. He postponed his trip by 2 months, simply that he could come and look at our system. Okay, so it's been running very well, very stable. Okay, I'm not going to go into Visi, except to say that we have been using Visi because we want these things. And these things, what WiZi does, it sends them to the infrastructure level, so we don't have to worry about them. And when we use Indigo, Indigo will give us much more, but it'll also give us this. So we'll be able to do this, plus do many more things in an easier way. But just let's say we want to do secure conversation. So there's a client and there's a web service, and I want to make this secure using secure conversation. I just wanted to give you an idea what the infrastructure is doing, which we are not doing. Previously, we would have to write code for that. This is all what the infrastructure builds for you. Okay, so the infrastructure does a lot of things to make sure that your message is secure. Okay, and we would have to write all this code ourselves if we were not using WiZi, or if we won't use Indigo. This code would go in our application code, and it'll be mixed with a lot of business logic. So by going to WiZi, and now by going to Indigo, a lot of this stuff will be done automatically for you. Now going to Indigo model is even simpler than WiZi. And so what's going to happen right now when we are doing WiZi, it's taking about students about a year to learn about WS security and WS different things, because you still need to know some of those things when you're using WiZi. But when you do Indigo, you don't even have to worry about those things. And so I think our students can be fully trained in Indigo within 3 months' time and be really productive, instead of having to do angle brackets all the time. So the benefits when we used WiZi, before that, we estimate, before that we built a system for the Department of Defense. And that system, if we compare it with that system, we estimate that we spent about, in that system we spent about 80% of our time dealing with security. And if you look just like count the number of lines of code and things, it seems that it's only 4% of that we're using now. So basically we chunked out 80% of our code, and we're letting Microsoft do that part for us. So its maintainability of the system is really enhanced because the separation of business logic and infrastructure logic are completely separate. Okay, this is...
Also, how long, tell them how long it took you guys actually to code it out.
Yeah, 9 months. It took us 9 months to have a production system. And again, it's because the infrastructure is built for you. The security was the thing where we spent almost all of our time. And with Indigo, it should be even more rapid development. So here is our client, and this client talks to all the different web services I was talking about. It can be, by the way, this is all .NET framework. This GUI was made in .NET framework, and we're really proud of this GUI. It's all designed using vector graphics and not bitmap graphics. So everything is initially designed in terms of curves and things like this, and only in the end it gets converted to bitmap. So if you want to change the size of this or anything, it's completely non-trivial. And each one of these, the shading, this alone has 50 elements of shading, which I designed by hand. So, if you look at it in real thing, if this light turns on, you will see that a little, you can see it over here, the lower part will start showing a little bit of orange in it because some light has been turned on.
You spent a lot of time on the UI then, I assume.
Yeah, I mean this thing is, if you cut a hole through it, you will see the desktop through it.
Oh.
You can have any arbitrary size shapes, because typically, when you do .NET type of GUIs, if you don't go to unmanaged code, the GUIs look a little bit not as sophisticated as native GUIs. But I think this one looks pretty good, and that's all .NET.
Yeah.
And it's very rapid. We spent a lot of time initially, but we can change this very, very fast. Because none of the thing you're seeing over here is originally bitmap. Everything is vector graphics. And so I can change the colors, the shading, small buttons, big buttons, anything. It's just trivial to change anything in it now. So the changes are very fast. We have made other GUIs which look very similar to this with components borrowed from here. Okay, so in this, you see that what you're seeing are vital signs. Someone has already recorded some operation that went into an OR, and now they're playing it. They're needles for browsing. This one is a medication action. There's this needle also, and this will move. And as the needle moves, whether you're browsing or you're actually replaying it, you'll see the vital signs. What you see over here is exactly the anesthesia record you saw on paperwork. But here you see it in this way. And the whole thing is just supposed to look like a media player or something like this. So we got very positive response to something which looks so simple and to do these type of things. So you can get all sorts of, there's a privacy mode. If an anesthesiologist is sitting in an office and looking at this thing and somebody comes in, you just hit the privacy mode. You'll see, you won't be able to see anything that is that should be hidden. And when the person goes, but when you're looking at it, you know which patient you're looking at. So you can keep on looking at observing the patient, and somebody else can be in the room, and all the information is confidential. Okay, so everything you see over here is what you will see on that form. So basically, we copied that form over here. Okay, equipment and tracking is another big thing. It's huge. The errors that are caused by patients being in the wrong room or the wrong place, or the errors that are caused by if you don't know if you misidentify a patient, or all those type of errors are huge. Billions of dollars of losses are estimated because of these type of things. So our next thing, which we already have designed part of it is already built. In 3 to 4 months, this should all be done. And I'm saying 3 to 4 months, we'll design it in Indigo, starting from scratch. So that's our goal. And we want security. We want all these type of things. So the way we are looking at tracking is that we have got 2 different parts of the system. One is known as OR Track, which is really a location manager. And then we have got location detecting applications. And these can depend on different technologies. They could be Wi-Fi. They could be depend on Wi-Fi if you wanted to. You could have RFID technology over there, or you could use the new modes that are coming out, very, very small, 802.15. They could use 802.15 protocol. Anyway, what we have done is we have split this problem into 2 different things. This will change a lot. We'll have new technologies. We'll have different things. This over here takes care of all the. This is actually the main engine, which mostly people forget about it. In a real hospital, this is the thing that's going to take care about serving the clients. So this thing, for example, let me give you an example. Let's say you have a patient, and then you have an inpatient, and then you can derive from this. And if you have an inpatient, how does the system know that it's an inpatient? That inpatient is a patient. Let's say you're making a client, and the client is saying, paint all patients red on the screen. How would you know that it's an inpatient, is a patient? The way to do is to have hierarchies in the schemas. So what we are doing is that we have got strong hierarchies. All the hierarchies are preserved in schemas. In the same way, entities, monitors, other things, they have their own hierarchies. Then we have location hierarchies. Okay? For example, a given room is in a given building, and another room is in the Ross building. We want to make sure that the clients don't make the mistake and put the wrong room in the wrong building. So those type of information this is all the schemas are going to make sure that the map of the hospital, so the whole map of the hospital is a schema, and the map of the hospital makes sure, that schema makes sure that you don't put the wrong room in the wrong hospital and things like this. Number 3, what about if you have a room? It happens quite often in a hospital that, let's say you're using some rooms for some purpose, and later on you put more rooms in it, or you change the purpose of the room. Okay, so we have got also information. We also have the functionality of rooms and hierarchies in functionality. Like this room is used for OR. What type of OR? Heart OR. Okay, or open heart or beating heart and things like this. You can have hierarchies there too. The idea about all these hierarchies are that your clients don't break when you add new things to them. Okay. As long as you know that an inpatient is a patient and you add an inpatient, the system knows it's a patient, it'll keep on applying the patient rules to the system. Okay. All the error checking will be done at this level. For example, you may have rules. You have rules that a given patient, let's say, cannot be on this floor. Okay. So those rules have to be there. But those rules also have hierarchies. You may have that an inpatient, you may want to refine those rules. So just like you have method overriding, we have got similar type of rule overriding within XML. So the XML can either add to the rules or override the rules and things like that. So this OR track, what I'm talking about here, is a real big application. It's the thing that really makes sure that errors don't happen. All these things do is they simply say, okay, I'm here. Okay, I'm patient number this and this, or I'm wearing this tag, and I'm in room number 3 or something. That's all. Everything else happens over here. So we've completely divided this functionality. So in some ways, we're insulated from the changes in technologies which will happen over here. These are things are changing on a daily basis. Okay, so by these type of trackings, things like this can happen. A patient is wearing a tracking device, or right now we can do it using Locate, where you just plug in a USB thing. The USB thing contains patient's picture. It contains patient's vital signs. You take the patient into an OR. You plug the patient in, or wirelessly you find what it is. Then the patient's picture flows to the monitor in the operating room. The picture is showing, the patient is showing exactly where the operation is going to be with a mark. And that picture will go right over there. The vital signs and other things will be there also. So another thing is, as the surgeons operate, they have a touch screen, and when the operation goes through, designed for a given operation, when it goes through different phases, they quickly touch the screen to say, okay, I'm in this phase. That information also goes in there. If you have a big plasma screen at the OR desk area, some flat panel, big screen, then you will be able to see which patient is in which operating room. Not just that, but which patient is under what state of surgery. The chest is open, or the 1 hour before surgery, and things like this. Right now, there's a nurse in the operating room, and she makes more than 60 calls per procedure to make sure the transport is ready. There's a big orchestration of these things, which can almost be completely eliminated by systems like this. And so USB Locate, we've already written. This thing is, we are designing straight away in Indigo. We're hoping then 3 to 4 months this should be done.
Are there any challenges in getting the surgeons to stop to do that?
No, it's these things they have already been doing that, and the reason is they need to figure out how efficiently they're using their operating rooms. And so the OR schedule is very, very tight. And when they run over, then there are problems. And they want to see which surgeon is routinely running over.
There's a competition, kind of. You can tell which surgeons get through which stages.
Not just competition, but there are surgeons from many different institutions, different places which come.
Yeah.
And so then the administration, right now, these things are not that automatic. but they look through those papers and they say, this guy is habitually late and stuff like this, and then they will take care of it one way or the other. Okay, so the OR, the system architecture, as I said, is we'll again use queuing. Lots of this stuff will be taken care of Indigo. We are hoping that by using Indigo, we'll shed more lines of code. We already are getting much better performance. LD sitting back there. We're getting much better performance than Wizzy, about factor of 5. And that performance basically means that before we were able to deal with hundreds of clients, and now we can deal with thousands of clients without doing anything else, just switching over to Indigo. These are different methods we are coming up with so that the input gets parallelized and goes into queues and things like that. But anyway, this is simply for scalability reasons and other things. I've already said this, but I'll say it quickly. So all these devices, the location devices, are simply saying, it says sending simple XML. But behind this simple XML, there's a huge schema which checks this, makes sure the rules are obeyed, makes sure the patients are in the right place, makes sure that, and as time changes and new entities are added and new patients are added, the system doesn't break because it has some type, well, it's not really polymorphism, but polymorphic type of behavior. As I said, entity, your patient is an entity, then there's an inpatient, outpatient, equipment is an entity, bed, monitor, things like this. The system knows about all that. There's a section of a schema which using extensions and using types and things like this, you can put all this information in the schema. Location, again, has hierarchies. Room 101 is in the first floor of the one building in University Hospital. And we want to make sure that these things are not put wrong, so the wrong room doesn't go into the wrong place. So all this type of checking will be done by us, so the clients are much simpler. We'll be able to write very lean, mean, simple, quick clients, because there are lots of different clients that'll use this system. There could be clients for the tracking of the patients or tracking of equipment, tracking of where all the laptops are, which are given to nurses. This is the concept of functionality, as I said. Room 101 tells us nothing unless we know that it functions as a cardio OR. And maybe later on, room 101 will be changed into a waiting room. One never knows. So all that information is in the system. This is just a little part of the map which of the hospital, which just shows the schema so that all the map is in there. By the way, the schema itself is fairly difficult, so we have a tool to generate the schema. So we make the map, and the tool generates the schema from it. So the tool is much easier. Angle brackets. And information like this, we have got one hierarchy on buildings, and for example, here's a floor type of hierarchy, here's a building type of hierarchy, and then containments and things like that. Just trying to show you that OR track does a lot of work, and mostly when people come to hospitals to send their tracking equipment or something, they're only talking about that little thing on top, I am here, but they forget about all these other things. Rules just don't apply to entities or to locations, but they are rules on relationships. And these rules also have hierarchies. And so we can have some general rules, and when we add some new type, here's an entity, and here's an OR entity, and here's a room functionality and patient room functionality. And you can add and make rules more specific, but if you don't, the system will keep on following those rules. So as you add new things, things don't break. Okay, that quickly shows you OR Locate. That's our USB Locate. thing I was talking about. A patient is wearing a USB device. The student really made it much bigger than it should be because now we have these very small ones. He kept on trying to make it smaller, but every time he gave this presentation, it became big again. I don't know what. So it's big again here. Okay, so basically what you do is you connect it to a laptop. Whatever is in the USB device gets populated over here, or if there are other servers in the operating room, patient's picture, allergies, things like this will come on there. Then it sends, using its own wireless card, it sends messages to OR Track. And then OR Track is the big thing which checks for rules and all these different types of things. That's already done. Wi-Fi Locate is a simple location thing. Patient is wearing some type of a Wi-Fi device following 802.11 protocols. And right now, we don't have a small device. We have a device of this size. So we have a kit, wireless kit. We can do all these things. What we're really waiting for is miniaturization of these things. And these things are happening very fast. I'll talk a little bit about this. But if you had that kit we have, you could somehow miniaturize it, Wi-Fi kit to this, we could do this. Okay, so the wristband devices on the patient's wrist. Okay, let me talk about this one. This is more interesting. That's Wi-Fi Track. What's happening is that the wristband talks to access points using ordinary 802.11 protocol. From these access points, it figures out what the signal strength is from all the different access points. It sends that information in ad hoc mode to wireless laptop. The wireless laptop then it has more computational power, and it uses some stochastic algorithms which are actually developed at MSR to figure out where the patient, where the wristband is. The reason why we need stochastic processes is simple triangulation is not good enough. Wi-Fi signals are very noisy, lots of different things are happening, but this technology called Locadio was pioneered at Microsoft Research, which uses hidden Markov processes and stochastic ways to reduce the error of location. So you can have an error of location of within 1.5 meters using this. Is Crum here? No. Because I have never seen him. He's the one who did this. So I'm going to meet him for lunch. Okay. So basically the idea is use the infrastructure of the hospital. All you have to do is to provide this device. New modes are coming out. The idea about modes are that they are going to be cheaper. You'll be able to. The only problem at this point is that Wi-Fi takes a lot of power. 802.11 is a heavy stack. 802.15 is a new protocol which is lighter, and there are modes out there, but they don't talk to access points which are using 802.11. But Intel is coming up with some modes in the next few months, iMode 2. They'll have Wi-Fi sitting up here, and it'll be consuming very little power. And at that time, we'll be able to put this device actually on a patient's wrist. So this is within a matter of a few months, things like this will start coming out. And then we'll be able to track patients using the infrastructure that's already there in the hospital. Okay, we don't have to add any new transceivers or things like this. If you estimate for 50 operating rooms and other places, if you try to put even RFID equipment, you'll have to put so many transceivers there that in the end the cost will approach $1 million. And we can do it for much less, almost nothing. And so that's our plan over here. And so, wow, a lot of information ended almost on time. It started late. Or am I? It was like, yeah. So here's the current and near future work. Currently working on OR Track, Wi-Fi Locate, Wi-Fi Track. We are migrating to Indigo. Ellie is sitting back there. We talk with him almost every 2 weeks, and got lots of good ideas at this very impressive training we had the last few days. So we'll continue doing this. It's very exciting. HL7 software factories, that's another thing we're really interested in working on. Again, the HL7 software factories, this is health level 7, will produce indigo artifacts. And so these factories will generate software that you can then, a family of software, okay? And then you can turn your knobs and dials and things to generate the specific type of HL7 software you want from it. Oops, went away. So these are the things we are involved with, so that's keeping our hands full. But we have a big team, and so that's good. Future plans are you should be able to have, after an operation, the patient should be able to send their vital signs back to the hospital. So you can monitor the patient. That's not such a big deal. We can do it today if we had the time. Or high performance visualization, that's another thing that I'm in touch with the high performance, what's it called, in Taiwan, their High Performance Institute, forgot their name, NCHC, National, anyway, I visit them every summer, but we end up making plans, but we haven't done anything. But one of the plans is to somehow be able to integrate with grid computing or high performance to do visualization and things like this, radiology or other things, and somehow plug that into our system. And voice-activated clients, it's a big need for that. So another thing we want to work on. But right now, we're really busy doing these things up there. Oh, thank you. Any questions?
I have one question.
Yeah.
So in one of your slides earlier, you had something about persisting the XML in a database.
Mm-hmm.
And what do they look like? Are they blobs?
Okay. Right now they're blobs, but we are looking at SQL Server 2005. And so I already bought a very nice big thick book on that.
Right.
So my students are reading it. We would rather not have them as blobs.
Yeah.
But right now we don't have it. We haven't finalized that. But I think SQL 2005 is the way to go.
Yeah.
And certainly we'll use all the XML capabilities. That's what excited us. Yeah. Nothing will go as a blob. No way. Yeah.
This particular application, why did you decide to go with message-based security rather than transfer?
SSL and stuff
Right,
like.
exactly.
Well, for one thing, we want when we persist the messages, when we want the security part to be persisted with it as fingerprints, so that we would. So even if you pull this out 10 years later, we'll have some type of information about who it was encrypted for, who signed it, and things like that. So the idea of the message carrying this with it and not being lost. Also, when we persist it, we rather persist it encrypted the way the message comes. And the idea that at some node your message is completely read and then redone is something we didn't want to do.
Okay.
Any more questions? Well, thank you for coming.
Thanks, Bert. Thank you.
See, it has changed.